attention, part 7, differential operator. Again, extrinsic geometry, 3D, okay? Generalized coordinates. Now, lecture 11, the property of the nabla operator. That's a very, very, very important property. Now, you see, since the curvilinear coordinates are independent, what this means, the partial derivative of Cj with respect to Ci is delta Ij because they are independent, okay? For instance, derivative of C1 with respect to C2 will be 0 because they are independent. So that's why it's delta Ij, okay, the chronic delta. Now, let's apply this operator here on this curvilinear coordinates Cj. Okay? From there, you see this case that Ai, now partial of Cj respect to Ci is delta Ij. Now, delta Ij acts on I and replace and put J over here. Okay, that's easy. So I can infer, okay, that Aj, attention now, this is contravariant base vector, is a gradient of Cj, okay, which gradient of Cj is perpendicular. Attention now. For instance, if J is 1, I have nabla C1. Nabla C1, you see, I have, let's put over here. For instance, I have here C2, C3. Now, this I have A1, A2. Now, attention now. At this point here, this I have nabla C1. This is a perpendicular to the, this is a tangent, this is the tangent plane here. So this is perpendicular over here. So nabla C1 is equal A1. Okay? Nabla C1 is A1. So nabla C1 is perpendicular to this plane that contains A1 and A2. That's a very, very important. Now, you see, now we can multiply dot product on this equality over here. You see, AI, you see AJ cross AK. You see, AJ cross AK. So the nabla, in this case, nabla Cj is perpendicular to this plane over here. See, that's a tangent plane. Tangent plane. So let's multiply both sides. Okay, this is a definition of AI. AJ cross AK divided by square root of J. So let's multiply both sides, okay, the dot product by AP. So AP here, AP over there. So we can, it's a commutative, okay? Attention now, only dot product of two vectors. A dot product of a vector and a second order tensor, you cannot communicate, discrete here. This is different, completely different, okay? Now, since we have dot product of two vectors, they can AI, AP is AP, AI. Now, you see here, so I'll multiply both sides by AP. You see, AP, AI. This is AI over here. So this is AI. See? AP dot AI. Okay? So now AP, look at here. AP dot AI is just delta IP. Clearly. Okay? From here, I'll write there. Now, attention now. This will be 0 for I different from P. You see, from I different from P, you see, this will be 0. Now this will be 1 when I here will be equal P. So you can look at here, okay? Now again, so I can write easily, okay, that AP dot AJ AK, see? Now this over here is delta I IP. Now if I erase P and set I, this will be exactly the square root of G. Why? Because this will be 1. This will be 1 for I is equal P. So for this will be AI, A dot AJ cross AK. So this will be 1. Look how interesting. If this is 1, I can multiply this 1 by square root of G. See? It's simple. Very, very simple. So I substitute right over here. Okay? AI dot AJ cross AK divided by square root of G is equal 1. Then I conclude that the numerator here is equal square root of G times 1. See? Where G is the determinant of Gij. I got this in previous lectures. I don't remember it's part 1, 2, 3, or 4, or 5, or 6. See? But we derived this. So this is an easier way to derive this mixed product is equal to square root of G. Now, so that's it. That's important property. Okay? That AI is perpendicular to AJAK. AJAK. So it's perpendicular to a plane. Okay? Right at the point P. This here is a point P, which I have the vector position. Okay? The position vector R at this point P over here. You see, I can derive A1, A2, okay, or AJ, AK, doesn't matter. That's it. That's a very, very important property.